Okay, so in this video we are going to look at one more example of domain range, and we'll look at a composite function and find its domain and range. And I believe it could be called a little bit of a challenging work. We would have a challenging problem sort of thing. And the second part of this video would be decomposition of a function. Decomposition means that you are given f of gx and you need to find fx and gx. So let's start with the first part here. My function is the two functions that are given are fx is equals to cos x and gx is equal to square root of x. So first we find f of gx, which is f of gx, which is f of square root of x, and which means we are giving f a square root of x, and so in this function here we replace x with the square root of x. So that is what I have here, and then I look at domain. Now here domain would basically be all the values of x which are positive. So because you got a square root sign here, which means you cannot have a negative x. X can only assume positive values. So my domain is quite simply this. And then range is straightforward because we know that cos x values varies from -1 to +1, so that will straight away give me y range as y lying between -1 and 1, and y being a real number. That part is okay. Let's look at g of fx, and that means I got g of fx, which is g of cos x, and that gives you square root of cos x. Now we have to find the domain, we need to think of all values of x which makes cos x positive. We need to have cos x positive because it is under square root sign. And a very simple domain could be this. You could say that x is x lies between -π/2 and +π/2. This follows from the unit circle, and we know that cos x is positive in this range, and that is start from -π/2 here and finishes at π/2. Very simple, and that could be the principal domain, but because it's a periodic function, so it's not enough. We need to have more here. Okay, so we know that it's a periodic function, so all these will also be part of the function. I'm just trying to work it out. So okay, I need to go from this. I need to go in both the directions, negative as well as positive. So I do this. Then I have that as well, -4π instead of 2π, and so on. And likewise, I also need to do in the positive direction. So I just add, instead of minus, I do +2π here, π/2 +2π, then I do a 4π, and so on. Now all these can be very easily represented if we just keep in mind that 2π is the period. So I could write all this thing as, I could say that -π/2 +2k π less than equal to x less than equal to π/2, plus 2k pi, and where k has to be, k is -3, -2, -1, 0, 1, 2, and so on, which basically means that k is a integer. Okay, when we take that into account, my domain is equals to x such that -pi.2, 2k pi is less than equal to x, less than equal to pi/2, 2k pi, where k is an integer. As simple as that. And then now we look at the range. I don't know why I always put a alley there. Now we need to see that cos x has only the positive value here. So the because the values of cos pi varies from -1 to +1, but because of this domain we'll only have positive values. So under the square root sign here, we are only going to have positive value from 0 to 1. So its range will be 0 less than equal to y less than equal to 1, and that finishes it. Next we will look at decomposition. We will have an FOGX and we'll need to find fx and gx. It would be fun to look at them, so I'll start with the first one. So say fog x equals to x squared divided by 1 upon x squared, and you need to find fx and you need to find gx. Now there are infinite number of solutions for this problem. I mean, you can have so many different values of fx and gx which would all give this. The simplest one is you need to think that you could put the whole thing in one function and keep the other one as a very simple function, just y equals to x. So, and it doesn't require much effort. So I could say gx is equals to x and fx is equals to x squared upon 1 plus x squared. Now in this particular case, you can check it. You can check that they give you this thing. They give you f fog x equals to this. Yeah, f gx equals to x, so we put there. And you can also try that in this case, if you try GOFX, then also you will get the same thing. And in this particular case, let's check. So GOF, you try to find G of x. So G of fx, which gives you G of x squared this, and gx is just x, so this is basically x squared upon 1 plus x squared. So in this particular case, fx equals to g of x. And this strategy where you put everything in your given function in one of them, one of fx or gx, is very useful. I mean, you can do it for every problem, but then you wouldn't learn anything. So we have to find it using a different method as well. So we could have a different method. So just let's see. We'll have one more. I'll give you one more solution. And the thing is, like, I'll start with gx equal to x squared. Then I think I want you to pause the video here and try to find out what could be the value of fx, so that you end up with fog x equals to this. Pause the video here and try it, give it a go. My solution is that because gx is equal to x squared, so fx is equals to x upon 1 plus x. And here you can try and you can check again that fog x equals to f of gx is equals to f of gx is x squared. Now I put x squared wherever there is a x, and I get x squared upon 1 plus x squared. I want you to find one more solution for this. And in fact, I can give you a solution. I can start you off and you can find the other one. So if I give you gx is equal to square root of x, what could be the fx to give you fog x equals to that? This I'll leave for you. Okay, and we can look at other example as well. So this one is say fog x is equals to 2 upon square root of 2 plus x square, and you need to find fx and gx. Now, just like the previous example, you could put everything in one function, all of this in one function, and another one could be equal to x. So we are not going to go there. I'll look here and I'll see that if I'll give you one function and then I would ask you to find other function. So gx equal to x square. What should be the fx here so that fog x becomes this? You can pause the video here and think about it. You just need to think. My solution is that if fx is equals to x square, if gx equals to x square, then fx is 2 upon square root of 2 plus x, and that will give you fog x equals to this. You can check this out. Yep, and you may find other solutions as well. I'll leave that to you. Let's look at one more, and this time I'll make it a little bit tricky. So fog x is equals to x to the power x times e to the power x. Now it's as I told you, first the simplest solution is just putting everything in one function and keeping the other one as x, but we'll not go there. Here I'm giving you value of gx, and gx is e to the power x. What should be the value of fx? Again, I want you to pause the video and give it a go. My solution is that I see that if I give e to the power x to fx, how can I get x e to the power x? So first thing is I'm giving this thing. Let me explain to you. So that thing is already there. You need to get a ex there. So what I will do is I'll keep x as it is. Yeah, because I need the x. I'm giving e to the power x and I get an e to the power x. So I'll keep a x there. But then I need to provide another x from here. So how can I derive an x from e to the power x? Very simple. You take the natural log. So that's my solution. That's my answer. Gx equals to e to the power x. Fx is equal to x ln x. Yeah, you can try this. Let's give it a go and let's test it. This fog x is equals to fog gx. Gx is e to the power x, and then what you do is you put wherever there is a x, you put e to the power x. So I'm giving e to the power x to fx. So in place of x, it becomes e to the power x, then ln e to the power x, which basically this is just the x. So you get what you were looking for. There are many solutions possible. I'm giving another one, but I'll just start you and then I'll ask you to do it on your own. You need to find what fx is gonna look like here. Okay, so next one, let's do one more, and this time if you remember how to do this, this next question should not give you any problem. It's just similar in format to the previous example. So how would you do it? I can start you, and then I think you should be able to complete it. So gx is equals to sine x. You should be able to connect or relate to this previous example, and I'm sure you will get it, so I'm not going to complete it. And I will give one more tricky problem to few people so that you can practice on it. I'll not give the solution now. So this time my f4gx is equals to 2 sine 2x e to the power x. And like the previous example, I can start you off. So the first one would be, I'll take gx equals to ax. That's one solution, and other solution I would suggest, and then you need to find out what f x is. And the other solution, I would give you gx is equals to sine x and gx is equal to sine 2x, and I wanted to find fx. I hope you would be able to find it.